All right, guys, we're going to go ahead and get started. So directions, please get out calculators, pencils, notebooks, complete the following writing prompt. So this says, if you know 2 points on a line, how can you find the rate of change of the variables being graphed? So this is what we've been discussing the past few days, talking about rate of change. So we did a little bit on Thursday of last week, and we talked about this yesterday. So when we think about, I just kind of wanted to see if you were able to put it in your own words, what we've been discussing. So when we're talking about the rate of change, I know it's hard to write on this, so my handwriting looks like crap. Rate of change, we talked about, we can find the change in rise, so y2 minus y1. So the rate of change is going to be change, in rise over the change in run. So over change in run. So what this means is our rise is going to be our y-axis, so up and down. So the change in y is going to be y2 minus y1. And remember, those represent points. So y2 is its own point. Y2 over y1 over x2 minus x1. I would definitely, if you don't already have that, that formula written down, that's going to be our rate of change and slope formula. Also, we can write it as rise over run. So you'll hear me say rise over run, rise over run. What that's saying is we're doing change in y over the change in x to see the change in our slope as we go up. So and I'll try and draw it down here. So if we've got, this is our graph, if we've got a line, I'm going to calculate the rise and then the run, the rise and then the run, and that should be a consistent change. So that should be a constant ratio with the rate of change and the slope. That should be changing at the same pace since it's a proportional relationship. It's a straight line, it goes through the origin. So we'll talk more about this in a minute, or let's see, admit. All right, let me go ahead and take attendance for those of you who just showed up, and then we will get started. So. Cool.
Hello.
We just went over our do now. So we talked about rate of change in rise over run. We're gonna get started with talking about unit rates now. So if you guys remember learning in 6th grade, you guys talked about unit rates. So the price per one or the speed per 1 mile. So if I'm buying a box of K-Cups because I'm a coffee addict, so I'm trying to figure out if I get a 12-pack of K-Cups for $12, the price per 1 K-Cup would be $1. So it's kind of dividing the total by the amount to get price per one or the unit rate. So you guys did learn about this in the 6th grade, practice it in the 7th grade. We're going to talk about it a little bit more right now. So a rate is a comparison of 2 quantities that have different units. So we've been talking about rate of change, and we're comparing unit rates now to slope. So such as miles an hour. So if you guys are on the highway and you see a miles per hour, so if you follow that speed, 65 if you're on the highway, if you follow the speed of 65 miles an hour, you should travel 65 miles per 1 hour. And go ahead and make sure everybody is muted, and then feel free to unmute yourself if you have any questions, okay? All right. So a unit rate is a rate in which the second quantity is in the comparison of 1 unit. So if I'm trying to figure out what the price is for one, that's what that means. So a storm is raging on Misty Mountain. The graph shows the constant rate of change of the snow level on the mountain. Find the slope of the graph using the points 1, 2, and 5, 10. Remember that the slope is the constant rate of change. So what we're gonna do, so I'm gonna go ahead and plot these points, and it's kind of hard on this computer, but so I'm gonna plot the point 1, 2. So I'm going to go over 1, up 2. So there's our point number 1. And then I'll do a different color. So the other one is 5 tenths. I'm going to go over 5, up 10. So up here. All right, so we are trying to figure out the rise to run. Sorry, I thought that was going to be thinner than it actually was. All right, so remember that slope is a constant rate of change. So we need to find the slope or the rate of change. Remember that formula that I just gave you guys, y2 minus y1 over x2 minus x1. So we're going to make, I'm going to highlight. So I'm going to make my y, or my first point, I'm going to make that 1, 2, and I'm going to make my second point 5, 10. So that's what it means. So if you guys remember yesterday when we talked about slope, we're picking 2 points and we're going to kind of set them up. So we're taking the second point and subtracting the change from the first point. So I'm going to go ahead and I'm going to set this up. So I'm going to take y2. So the y on our second point is 10. So I'm going to take 10 minus y1, which is 2. And then I'm going to take, that's going to be all over x2. So that's our second point. We've got 5 minus x1. Okay. So 10 minus 2 is going to give me 8. 5 minus 1 is going to give me 4. So our rate of change is going to be 8 over 4. And this means that, let me see if I can erase this and kind of show you guys what that looks like. So this is meaning our rise is going to be 8. So 1, 2, 3, 4, 5, 6, 7, 8. Our run is going to be 4. 1, 2, 3, 4. So that is our rise over our run. So that is our rate of change for that line. So if we wanted to figure out further up the graph, we could using this slope that we got. So find the unit rate of snowfall in inches per hour. Explain your method. So unit rate of snowfall. So we want to figure out, so this is saying, so it's hard to conceptualize, and it's hard because I don't have a bunch of visuals and I only have a small screen to show you guys. So if we're looking over here, time H is going to be our X value. Snowfall in inches is our Y value. I'm comparing snowfall in inches per hour. So doing Y over X, so that's what we're comparing. So we want to figure out what the rate is in 1 hour. Well, actually, we already have that because our X, so if I said X is, and I'm trying to figure out a way to show you guys this without a bunch of visuals and videos and stuff like that. So find the unit rate of snowfall in inches per hour. And then, so that's what we're trying to figure out, inches per hour. So if I, let me see, let me get my pen. So inches is X per hour. I'm sorry, inches is Y, duh, it's up here. Inches is Y per hour. So Y divided by X. So 8 over 4 is our rate of change. If we want to simplify that, we can go ahead and we can divide both by 4. If you guys remember simplifying fractions when you guys were in 6th grade. So we can take 8/4 and simplify that. We can go ahead and divide both top and bottom by 4. So I'll actually show you guys kind of what I mean. So I'm going to divide the top by 4 and the bottom by 4. And that's going to 8 divided by 4 gives me 2. 4 divided by 4 gives me 1. So the unit rate of snowfall in inches per hour. So remember, time is in hours, so that's X. Snowfall in inches is Y. So inches is on top, per hour is on bottom. So this means that at 2 inches every 1 hour, that's what the rate is going to look like. So find the unit rate. So every hour, it will snow 2 inches. And this information is actually really helpful for us because we are able to, we can take, so if we wanted to know how much it snowed in 10 hours, 12 hours, 30 hours, we could actually use this. If it's going to snow at a consistent rate, we can use this. So we could know that in every hour it is going to snow 2 inches. So compare the slope of the graph and the unit rate of change in the snow level. What do you notice? Well, we know that the slope of the graph and the unit rate are actually going to be the same because that first initial point that they gave us, 1, 2, it starts right there. So 1 hour, it snows 2 inches, excuse me. And then that unit rate, we can actually use that. So at 2 hours, it's going to snow 4 inches. At 3 hours, it's going to snow 6 inches. So we're always going to stay consistent on that line. So compare the slope of the graph to the unit rate. So we should be noticing that they are the same. All right. Graphing proportional relationships. So you can use a table and a graph to find the unit rate and slope that describe a real-world proportional relationship. The constant of proportionality for a proportional relationship is the same as the slope. So constant of proportionality is the same as slope. So we've actually been learning this, but we're going to be kind of talking about what that means a little bit more within a context. So Thomas rides his bike at a steady rate of 2 miles every 10 minutes. Graph the situation. So on our x-axis, so I'm going to write x-axis, y-axis. So he rides 2 miles, so 1, 2, every 10 minutes. So 2 miles every 10 minutes. So graph the situation, find the unit rate of this proportional relationship. Well, if he graphs, so if we're thinking about a table, I'm actually going to set up a table for us because we did talk about constant of proportionality. So this actually should be pretty easy for us to figure out what comes next. So, so if we got x is 2, so he rides 2 miles every 10 minutes, we should be able to find the unit rate. So remember that constant of proportionality is going to be y over x. So if we take y, which is 10, and divide it by 2, that's going to be, so 10 divided by 2. So if we're taking our k equals y over x, 10 divided by 2 is going to give us 5 over 1. Because 10 divided by 2 is 5, anything over 1 is itself. So y is going to be 5, x is going to be 1. So what this means is the constant of proportionality is going to be 5 over 1. So meaning y should be jumping, and I guess it'd be, hold on, it'll be easier if I switch these. I'm not doing any math, I'm just switching them. So I'm going to put 1, 5 up here, and then 2, 10 down here. So this is saying that 5, if the constant of proportionality is 5 over 1, y should be changing at a rate of 5 every time. X should be changing at a rate of 1 every time. So find the unit rate of the proportional relationship. The unit rate is going to be 5 over 1. And remember, unit rate means anything per 1. And this information can help us because if we know that for every 1 minute he is going 5 miles, we can figure out how far he goes in 20 miles, 2 miles, 6 miles, 800 miles. If he's going at that same pace, we can figure out how far he's going. So we can use this information to help us plot points on a graph as well. So if we're growing by 1 each time, growing by 5 each time, you could continue to make a table like this. So if we're going to grow by 1, we're going to grow by 5. So you can continue. So this is saying in 4 minutes, he's going to go 20 miles, that kind of thing, which is kind of far, but I guess he's biking, so that makes sense. All right. All right, using slope to compare unit rates. So you can compare proportional relationships presented in different ways. So the equation y equals 2.75x represents the rate. And if you guys remember, we talked about constant of proportionality is K equals Y over X. Sorry, I'm trying to write it so you guys can see it, but it's not working. Let's try this again. So K equals Y over X. I also told you guys that we can rewrite this equation as Y equals KX. So here, at 2.75 is representing our constant of proportionality, or our rate. So the equation Y equals 2.75x represents the rate in barrels per hour that oil is pumped from well A. The graph represents the rate that oil is pumped from well B, which well pumped oil at a faster rate. So we have to use, so we're going to follow these steps. So this says use the equation Y equals 2.75x to make a table for well A's pumping rate in barrels per hour. So we already made the table, they already have the table for us. So in 1 hour, we've got 2.75 barrels filled or pumped from, so oil that's pumped from the barrel. So in 1 hour, we pump from 2.75 barrels. In 2 hours, we pump from 5.5 barrels. 3 hours, 8.25 barrels. 4 hours, 11 barrels. So at this rate, so this means we're jumping at a certain rate. So in this one, I can already tell we're jumping at the rate of 1. So we're jumping at 1 per hour. And then at the bottom, we can actually find the difference between 5.5 and 2.75. So 5.5 minus 2.75 equals 2.75, which makes sense. I just wanted to make sure that checked out. So for this one, we're moving at a rate of 2.75 every single time. So for every 1 hour, 2.75 barrels are used. So use the table to find the slope of the graph of well A. So we're trying to find the slope. The slope and the unit rate are the same thing. So what I just did is I found the rate of change. So this is taking Y2 minus Y1. So I'm going to use my highlighter to hopefully make this a little bit easier to understand, because it is hard, and it's really hard for me teaching this online. So I'm really sorry. I'm hoping I'm doing a good job just trying to get this information across to you guys. So we're going to make this 0.1 and we're going to make this 0.2. So this is 0.2. So this is the 5.5 minus 0.1. So that's where those numbers are coming from. If you guys are confused, remember we're taking Y2, so 5.5 minus Y1, 2.75. And so the slope and the unit rate for this one is 2.75 barrels per hour. Step 3, use the graph to find the slope of the graph of well B. Slope equals unit rate equals rise over run. So slope, rise over run, unit rate, constant of proportionality, all the same thing. We call them different things just so we can kind of build up that understanding, but they are all the same thing. They're the rate in which a line is going or a proportional relationship is extending. So if we're taking rise over run for well B, so rise over run, I'm going to go ahead and pick a point on, so we've got, let's see, that doesn't actually touch. Let's see. I'm going to pick a point. So I'm going to pick this point right here and this point right here. So all they want to do is they're trying to pick the rise over the run. So the rise, so if we start down here at the origin, the rise is going to be 10. So 2, 4, 6, 8, 10. The run is going to be 4. 1, 2, 3, 4. And I know it looks like I'm jumping by 2, but this this graph is moving in increments of 2, if you can see that. So our rise over our run is 10 divided by 4, which is 2.5 barrels per hour. So we're comparing the unit rates now. So we're saying, okay, if well A, or what is it? Yeah, well A is doing 2.75 barrels per hour. Well B is doing 2.5 barrels per hour. 2.75 is greater than 2.75. So well A's rate is 2.75 barrels an hour. So that is faster. So I know this is a lot of application and kind of trying to understand what is going on within a context. Let's see. I think this is, let me double check. Yeah, we're almost done for today. So we're in the home stretch. So the and guys, this is a lot of skills in one. We're gonna spend a lot of time on slope. So we're gonna spend a lot of time practicing graphing. We're gonna so if you're not getting it right away, don't panic. This is a lot of application. So we will work on this for sure. All right, the equation y equals 375x represents the relationship between x, the time that a plane flies in hours, and y, the distance the plane flies in miles for plane A. The table represents the relationship for plane B. Find the slope of the graph for each plane and the plane's rate of speed. Determine which plane is flying at a faster rate of speed. So I'm gonna do a couple things. So at home right now, I would suggest doing this. So I'm already noticing, so I've got an equation, and this represents plane A. I've got a table, and that represents plane B. So for plane A, oh my gosh, it's so hard to write. I'm sorry, guys. All right, I'm trying. Plane A, there we go. So plane A, our equation is y equals 375x. So, and if x is the time that a plane flies in hours and y is the distance, this is saying that we don't, so we can multiply the rate of change or the speed, 375 times the time that a plane flies in hours, and that should give us the total distance that the plane is gonna fly. That's for table A. Table B, or I'm sorry, plane B, so plane B. So I'm gonna look at this table now for this one. So this right here, if you guys remember earlier, this is K. So this is our constant proportionality. It's our unit rate. So this is the rate in which it's changing. So this is saying in 1 hour, it's moving at a speed of 375 miles. So if we wanted to look at this and figure out a rate of change, we could, and we're gonna do that. So I'm gonna go ahead, I'm gonna highlight point 1. I'm gonna highlight my point 2. Okay. I'm gonna go ahead, I'm gonna take Y2, which is 850, Y2 minus Y1, 425. And then I'm gonna take X2, which is 2, minus X1, which is 1. And if you guys remember, this is coming from our rate of change formula or our slope formula. So in my calculator, I can go ahead and take 850 minus 425. And that's going to give me 425. 2 minus 1 gives me 1. So our rate of change is going to be 425. And actually, I just wanted to make sure you guys knew where this number was coming from, but it actually already gives us our distance in miles, which is 425 miles per 1 hour. So it actually already gave us our unit rate, but I just wanted to make sure we knew how to find it if we needed to find it on our own for some reason. So this is going to be our rate of change. So we can write our equation as y equals 425x. So for this, it wants us to graph the line. So I'm going to make, let's see, highlighter. I'm going to do plane A in this pinkish color, and I'm going to do plane B in this bluish color. So plane A. So this is saying for every 1 hour that goes by, so if I've got 1 hour down here. Oops, that's not what I wanted. So 1, 2, 3, maybe I'm trying 4, 5. So for every 1 hour, plane A goes 375. So on our y-axis, we need to label. So this bottom is going to be time in hours, and then the side is going to be distance in miles. So for every 1 hour with plane A, we go 375. So what I'm going to do is I'm going to write, I'll do this actually in pen to make my life easy. So we'll do 50, 100, 150, 200, 250, 300, 300, and oh gosh, 350, 400, sorry guys, 450. This is actually my first year ever using Smart Notebook, so I'm sorry, I'm trying to get it. All right, let me get my highlighter again. So if I'm looking at 375 miles, so that's going to be about here for every 1 hour. Boom. That's going to be about right there. So if I'm looking at 425 miles for every 1 hour, 425 is going to be about right here. So because plane B is moving at a faster speed, these lines that we would draw for their proportional relationship, oh, that's not a great line, it's because I don't have a ruler. But plane B would ultimately go further. So which one's flying at a faster rate of speed? 425 miles per hour or 375 miles per hour? 425 miles per hour is faster. All right, so I wanted to go over, I thought this lesson was kind of a challenge to grasp for you guys, just because there's just a lot going on. So major ideas and takeaways. We can represent relationships between numbers with equations, graphs, and tables. Slope and rate of change are the same thing. So a few other things that I wanted to make sure that we know about. Classwork. All right, so this week you do have a quiz over rate of change and slope. I'm going to go ahead and show you it so we can talk about what is expected. Let me just go to, so rate of change and slope. So the table, let's see. So the table below represents fabric measures, tell whether the rates of change are constants or variable. Remember, when talking, and you might want to write this down because it's on your quiz, the difference between a constant and a variable rate of change. A constant is going to be changing at a constant rate. So you're going to have to find the rate of change between 2 points and then figure out, is it constant or is it going to be changing at a variable speed? So is it changing at the same speed? That would be constant. If it's changing, if it's jumping from 2 to 5 and then 5 to 12, then it's jumping at not the constant speed. So you're gonna have to figure that out. It wants you to find the rate of change from 1 hour to 2 hours. So it wants you to figure out how much we're changing per hour for that one. So these are kind of, these per problems, those are unit rate problems. So it wants you to figure out the price per pound, the cost per batch, that kind of thing. Like to constant speed, show the distance, or the graph shows distance over time, find the rate of change from 1 to 3 hours. So for this type of problem, I would recommend plotting the points on a table, so taking them out. So for this one, this is at 0.14, this is 0.28, and I'm gonna have you guys do practice problems for plotting points next week, because I think we do need to have some practice with that. So for these types of problems, you're going to be finding the rate of change and then finding the slope. So that's what we're going to be doing the rest of the week. Let me make sure. Slope practice, this is just going to be, what's I going to say? This is just completion. However, use it as a practice to see if you guys are understanding what's going on. If you guys need help with anything, you can always email me. So can you find slope? Can you determine if a slope is positive or negative? Which I'll talk about a little bit more tomorrow. What is the slope between these 2 points? What does the formula represent? So this is just real quick practice for you guys, but I'm gonna add some more practice for next week just so you guys can practice plotting points, that kind of thing. All right. I'm gonna stop recording and I'm gonna let anybody ask any questions that they may have.